Tamil Nadu, India. This conference brings together researchers, academicians, and industry experts to share their knowledge and research findings in the field of smart infrastructure, artificial intelligence, sustainable development, and emerging engineering technologies. Today's conference is structured with a keynote address, followed by two technical sessions in the computer science engineering domain, where researchers will present their valuable research paper. I request all participants to actively engage, ask questions, and provide feedback to make this conference interactive and successful. Now, I would like to move to the keynote session. It is my honor to introduce our keynote speaker, Dr. M. Hemalata. Dr. M. Hemalata completed her Doctor of Philosophy in Computer Science from Mother Teresa Women's University, Kodaikanal, in the year of 2009. She is working as Associate Professor in PG and Research Department of Computer Science at Sri Ramakrishna College of Arts and Science, Coimbatore, Tamil Nadu. She has guided 32 PhD scholars. She has more than 2 decades of experience in teaching and research. She has published more than 200 research papers in international journals and also presented more than 100 papers in various national and international conferences. She filed 2 patents in the field of deep learning. She received Best Researcher Award in Karpagam University in the year 2012 and Nehru Women Excellency Award in the year of 2020. She won silver medal for developing an e-learning tool for children with the autism disorder exhibit at International Engineering Expo at Malaysia. Received a travel grant from DST to attend an international conference at Singapore in 2011. She is active member in various professional bodies in the field of computer science. She also visited and presented her research contribution to China, Singapore, Hong Kong, Malaysia, Dubai, Israel, and Thailand. Her research areas include data analytics, data mining, bioinformatics, and neural network. She is a reviewer in several national and international journals. We are privileged to have her with us today to deliver the keynote address. Madam, I kindly invite you to deliver the keynote address.
Able to hear me, sir?
Yes, madam.
Hello, sir.
Madam? Madam, கேக்குதுங்களா?
Recording in progress.
மேடம் கேக்குதுங்களா மேடம்?
சார் எனக்கு ஃபோன்ல கேக்குது. நான் லேப்டாப்ல பண்ணியிருக்கேன். ஆனா லேப்டாப்ல ஏன் வாய்ஸ் வரலன்னு தெரியல. ஒரே நிமிஷம்.
இல்ல உங்களை நான் இன்ட்ரடியூஸ் பண்ணேன்.
அதான் எனக்கு வாய்ஸ் எங்களோட கேட்கல. சார் இப்போ என்னோட இதுல இருந்து பேசுறேன், கேக்குதா சார் இப்போ உங்களுக்கு? பட் எனக்கு நீங்க பேசுறது எதுவுமே எனக்கு கேட்கலையே.
மேம் ஆடியபிளா இருக்கு மேம். மேம் வாய்ஸ் ஆடியபிள் மேம்.
Alexa. Good morning, madam. Madam, good morning.
Sir, Janagi Raman, sir.
Janagi Raman, sir, from PMC, Hosur.
Also, sir, good morning, sir.
Good morning. Good morning.
Sir,
good morning, sir. What is my
ma'am
time, sir?
audible வந்து ஏதோ ப்ராப்ளம் இருக்கு போல. Ma'am is checking that
Okay.
side, sir.
Okay, sir.
அவங்க ஹெட்செட் வச்சுட்டா தான் கரெக்டா இருக்கும் சார்.
சார்
அவங்க ஹெட்செட் வைக்காம இருக்காங்க, அதை வச்சா கரெக்டா இருக்கும்.
ஓகே,
அதனால நம்ம பேசுற வாய்ஸ் கேட்கல.
இல்ல அப்ப இவங்களை இன்ட்ரடியூஸ் பண்ணதும் உங்களுக்கு கேட்டிருக்காது இல்லையா?
ஆமா, அதான் அவங்க ஹெட்செட் இல்ல, அவங்க அந்த சிஸ்டத்துல அவுட்புட் எப்படி இருக்குன்னு தெரியல. ஆடியோ
என்ன நீங்க சார் இதுல எப்படிங்க சார்?
மேம் த்ரூ யுவர் மொபைல் ஃபோன் கிளியரா இருக்கு மேம். நான்
ஹெட்செட் போடல. ஆனா நான் டைரக்டா லேப்டாப்ல இஷ்யூ இப்படிதான் பிரசன்ட் பண்ணுவேன். இன்னைக்கு என்னவோ அது ஸ்கிரீன் எல்லாம் இதாகுது. பாத்தீங்கன்னா இதுல மைக் இருக்குது, ஆனா சவுண்ட் வாய்ஸ் கேட்க மாட்டேங்குது. உங்களுக்கு நான் பேசுறது அந்த ஸ்கிரீன்ல கேக்குதா உங்களுக்கு?
எஸ் மேம், கிளியரா இருக்கு.
எனக்கு தெரியல.
சரி நோ ப்ராப்ளம். இப்படியே நீங்க கன்டினியூ
கேக்குது
பண்ணுங்க
மேடம்,
மேடம். உங்க
கிளியரா
லேப்டாப்ல
கேக்குதுங்க.
ஷேர் பண்ணுங்க மேம்.
பாருங்க ஹெட்செட்டே போடல நானு. டைரக்டா தான் பேசுறேன். நான் யூசுவலி இதுல இப்படிதான் பேசுவேன்.
இல்ல நோ ப்ராப்ளம் மேம். நீங்க லேப்டாப்ல நீங்க
Unmute
ஷேர் பண்ணுங்க மேம்.
பாருங்க அந்த இதுல பாருங்க. இப்போ நானும் மொபைல்னா வரும்னு நினைக்கிறேன் சார். ஆனா இதுல என்ன நம்ம சைடு ஸ்கிரீன் ஷேர் பண்ணிடலாமே அப்படின்னு பார்த்தேன்.
இல்ல
மேம்
ஒண்ணும் இல்ல, அவங்க
லேப்டாப்ல
ஒரு
நீங்க
ஹெட்செட்
ஷேர்
போட்டா
பண்ணுங்க மேம்.
சரியாயிரும்.
எப்படி நான் மொபைலே கனெக்ட் பண்ணிட்டுங்களா?
கனெக்ட் பண்ணுங்க மேம்.
மொபைல்ல 10 பட்டன் இருக்கு. சொல்றேன். ஷா மேம் ஒரு நிமிஷம் இங்க வாங்க. இதுல பேசினா உங்களுக்கு கேட்க மாட்டேங்குது உஷா மேம். என்னோட போன்ல இதுல நான் இப்படி எனக்கு வரும்ல, பேச முடியும். ஏன் ஹெட்செட் வேணும்?
அப்பதான் பேச முடியும்.
வேண்டியது இல்ல மேம். இதுக்கு லேப்டாப்க்கு எதுக்கு ஹெட்செட் வேணும் உங்களுக்கு?
நீங்க பேசினா கேக்குது.
இப்படி நான் நிறைய நாள் பேசியிருக்கேனே, பிரசன்ட் பண்ணியிருக்கிறேனே. அவர்தான் கூப்பிடுறாரு. ஹலோ சார், கேக்குதா? ஓ சரி சார், அப்ப நான் இப்ப ஸ்டார்ட் பண்ணிடுறேன்.
மேம் எஸ் மேம் கேக்குது மேம்.
ஓகே ஓகே. Good morning, everyone. So, really, it's a great pleasure for me to be a keynote person of this conference. So, I really congratulate the organizers of the conference, International Conference on Smart Infrastructure and Sustainable Development and Engineering. So, really, it's a great thing. I just so really this conference, I congratulate all the organizers of this conference. Really it's a excellent one, excellent title, and I really enjoyed. So I think most of the papers are reviewed, and each and every paper was really a worthwhile one. Okay, so today just we are going to discuss about some recent trends in research. We all know, even though it's a title is a smart infrastructure and sustainable development, I wish to share few things about the research. I know almost each and everyone you are going to present your research papers. So what is the recent trends in the research we should know? So the main I'll share my slide one second.
keynote speaker இவங்க ஒருத்தர் பேசுறாங்க 10:30 வரைக்கும்.
Yeah, so just we'll start with what are the research trends. So just we are going to see an overview of the recent methodologies and what is the policy relevant to the research, and a little bit about the emerging technologies, and we'll see lightly about these global perspectives, and we'll see some interdisciplinary approaches. That's all. So I'm not going to take much time. So just I'm going to give a simple introduction of the recent trends in research. So coming into the current landscape of the research is, we all know that there is a data-driven insights. So we all know the big data analytics is an important field at present. So this is the important thing in this data-driven and highlights of this research. So if you are utilizing the big data and analytics to drive research is reshaping the industries. We all know that. So each and every day the data is increasing, not millions or billions or more than that, the data are increasing. So this is an important field we have to be concentrate as a researcher. And the second one will coming into the interdisciplinary collaboration. So we are, that is without all the fields, the computer science is nothing, we all know. So we are supposed to be integrate with the various fields, then only that collaboration will be always good. And the third one what we are supposed to concentrate is user centric approach. So that is another important field we are supposed to concentrate. Without the users centric, there is no use at all. We all know, right? So the putting the end users at the center of the research. So we are going to start any research, we have to decide which user going to be benefit about our research. And the fourth one is the globalization of the research. So that research should be globalized. So otherwise also the research is not that much will be good or useful. So nowadays we are doing a lot of research in this field, but still we are supposed to be concentrate all these things. In future, if we concentrating all these things, will be consider all these points in our mind, then the research will be a good one. So what are the emerging trends if we coming into this particular area? We all know that AI and machine learning is an important field. So each and everything, the human resource, almost we no need human resource like that kind of field we are entering. So we need AI in machine learning is an important field. That what we have to do is we have to do some new possibilities in this particular field, that is data analysis, predictive modeling, then revolutioning research methods, and so many things are there. Still we have to concentrate for the new possibilities. And the second one is the virtual reality. This is also another field. So here the people are transporting the research to the immersive environments and simulating the creativity and enhancing the data collection. So in the fourth field what we are supposed to be concentrate is nanotechnology, nano learning. So the nano learning is also an important thing, that is we can call it as a micro learning, and especially this refers to the educational approach and to the many fields. And the fourth one what we have to be concentrate is blockchain technology. So the security aspects is always important. The blockchain technology is giving a very good security, so we are supposed to be concentrate on this, because there is a transparency, especially in but this particular field, not only security, there is a transparency. So this research data is also be this field also to be concentrated by the researchers. These are the emerging trends in future. Already you all going to present so many papers in this conference. Still, if you concentrate on these particular fields, your research will be always highlighted, and we'll see some impact of this technology. So what is the impact? So always these three important points should be there in our research. We all know that. The first one is enhanced data collection. So for data collection, at present we'll be having lot of powerful tools to collect the data, but powerful tools and sensors are more accurate and extensive data collections. So it is leading to the robust research outcomes. So okay, so we are having the previously we don't have this kind of tools, so we'll be struggling with collecting the data. We have to do the field visit, and we have to go for meet the particular person. Even the medical data also we have to meet each and every places, and then we have to collect many data. But at present, not like that. Just we can prove our results through the benchmark data sets. All those data we can collect it through lot of powerful tools are available. Few of them are very free, and few of them are we have to pay and collect the data. So these data are more accurate for us to complete our research, and we can show the excellent result in this. So the 10 years data collection is the impact of the new technology at present we'll be having. And the second one, what we are seeing is the efficient analysis. Here we are having advanced algorithms and high performance computing to speed up the data processing. So initially we'll be having very limited algorithms. If we consider for the data mining or something, we'll be having very limited algorithms to concentrate. But now it is not like that. We are a lot of hybrid data analysis, and so many things are there. So advanced algorithms. If we go for the mathematical people should concentrate on mathematics. So we'll be having lot of algorithm which is developed in the mathematical field. So better any researcher, my suggestion is, if anyone want to do an excellent research, or you want to do a new algorithm, you want to find a new algorithm, new field, then better you can concentrate on the journals which is released by the mathematics. You give your importance to the mathematical journals. There you will be having lot of algorithms still not yet used by the research people. So if you concentrate on those kind of algorithms, really your work will be highlighted. And this is high performance computing is always used to speed up our data processing. It's why we want to speed up. We will be complete our research in the expected time. So that will be the main thing. So we'll be consuming the research tasks, we'll be having a time so that you can close it if you do the analysis in efficient. So if you want to do an efficient analysis, what we have to do, we have to go for the algorithm should be in the advanced one. But how we'll be getting all these kind of algorithms? Better if you concentrate on mathematical journals. Other than you have to concentrate on mathematical analysis. That will be a great thing for us to do our research in time. And the third one, what you have to concentrate on this impact of this technology, collaborative research. This technology enables global collaboration. If you have a collaboration in your research, really it is a fruitful one. It is connecting researchers in the worldwide, and you can share your knowledge, and you can get help. So the same field. So one of my scholar, she did a research along with a person from Singapore and Malaysia and Thailand. So all these three institute together, she is also concentrated. She has done a research. That research was really an impact and a very nice one. Everyone was appreciated that particular. Still, the results we have not yet produced, so I cannot tell all those things. So, but the research was really good. She is concentrated on all these things. So. If you want to do a good research, you have to use powerful tools what we are having at present in the data collection. And second one, if you want to do an efficient analysis, you go for the advanced algorithm. If you want to make your research in the international level, definitely you have to go for the collaborative research, the last one. So we have to, after completing all these things, we should have concentrate on ethical considerations. So here the data privacy you have to maintain, because it is you are safeguarding the personal information and ensuring the responsible handling of the sensitive data in a research. So the data privacy, you always to put an eye on this. And the second one, research integrity. Here, adhering the ethical guidelines you have to follow to protect your so suppose you are collecting some real-time data, or suppose you are collecting some medical data, then you have to definitely the privacy should be applied. And also you have to some research integrity, also some research integrity in the sense you have to follow the ethical guidelines of the research. And the third, you have to concentrate on minimizing the bias. You should so that should not come, you should not attain that. You should have an awareness of the mitigation of the potential bias and fostering the impartiality and objectivity in the research. These are the ethical consideration you have to concentrate. Then if you do the research, there definitely that research will be really a fruitful one. And finally, we'll see the challenges in the research. Here, if you are doing a research with the funding agencies, really it is a great thing. So how to do these funding constraints? You have to, before you are doing a research, you just concentrate all the funding agencies. There you see the call for proposals. That particular subject you have to concentrate. So if you want to funding of the particular research, the main thing, the most of the researchers are lagging in this field. So the reason is we should have a papers, we should have a paper should be published in the reputed journals like Scopus, Willy, like that. So there you have to publish your papers. Apart from that, that paper should be in a particular field. Suppose you are doing your research in a data mining, all your papers should be addressed in data mining field. Then you have to go for a funding, then you will, your proposal will be sanctioned. Suppose you are doing many papers in a different field, but you are having a Scopus research papers, you are having 10 Scopus research papers, but you are having different fields, then the funding will not consider your proposal. So the people are expecting, or you having a excellent knowledge in the particular field. That is the most important. So this is the funding constraint. And what is the challenge we are facing at present? Data quality assurance. You have to ensure the accuracy and the reliability of the data can be complex and affecting research conclusions. So it is always there, but still you have to be concentrate the quality assurance. This is the another challenge we are facing, but you should do it. And the third one, time constraints. So once if you are starting your research in the 2020, once you are started, but you, at least you have to complete in at least 2023 at least, maybe 24. If you extend that, automatically your research will be a little bit outdated, and again you have to extend it. So and so time constraint is always there. You have to complete, you have to balance the research demands, and you have to maintain the quality according to the demanding of the research, and you have to complete within the time period. And the final one, you have to changing the paradigms. So what you have, it is sometimes some people will be start in one direction, suddenly they will be shifting. So that should not be encouraged by the researchers. So you should not concentrate all those things. These are the challenges what present we are facing. We have to give much concentration on all these things. Now finally we'll see the successful methodologies of that. So what are the methodologies we are doing here is the field research. We all know. So we have to collect the real world data sets. That is the field research. Because if you are going for some agricultural data, so we have to collect some particular area. So that way we will be going for the field research. And the qualitative research. So some need qualitative in the sense you are exploring or irrigate some human experiences or emotions. In that perspective, will be going for this qualitative. And the experimental studies is some testing hypothesis, so controlled experiments, uncovering the cause and effect. All this relationship will become under the experimental studies. The finally meta-analysis, the pooling from the multiple studies, different fields. We are collecting all the data and we will going for this is a successful methodologies. Already people, those who are doing research is following these methodologies. Still you have to give more concentration on these methodologies. So overall, the suggestion of the research is to you have to give more concentration of particular field. Always you publish a paper only one field. Don't go for scatter your publication of papers, then you will not go for the funding. So the funding is the most important. If you are getting funding from the DST, DBT, say, and CSIR, ICSISDE, so many funding fields are there. If you give concentration on funding, then your research will be always peak. So it will be a successful research, and you can get lot of good appreciations from the field of the research. So our research should speak everyone. So we have to concentrate all these things. Thank you so much. Thank you for the opportunity. Thank you, sir. Thank you. I thank Dr. Karthikeyan, sir. So he's the one doing organizing this conference, and really it's a great thing. And I appreciate all the the people, those who are behind this conference, organizing this particular conference. I congratulate them for the successful ending of this conference. I thank everyone for the opportunity given to me to share my knowledge within the very limited time period. I am unable to give you a proper thing. Still, I have come to, gave some what are the things what my experience I just shared with you. Thank you so much. Thank you, sir. Thanks a lot. Yes. Sir,
Ma'am, thank you, madam.
sir.
Ma'am, thank you, ma'am. Hello, madam.
சார் நம்ம பேசுறது அவங்களுக்கு கேட்காது. நீங்க அவங்களோட போன்ல சொல்லிருங்க. அதான்.
Okay, okay, sir.
Okay, sir. Okay, now inform to them.
Karthikeyan, sir.
Recording in
Yes,
progress.
yes, sir.
Sir,
Ma'am, thank you, ma'am. Ma'am,
கேட்டுச்சுல
thank you.
sir.
Thank you, ma'am.
Thank you, sir. Thank you
கேட்டுச்சு
so
ma'am,
much, sir.
கேட்டுச்சு.
Okay,
Thank
okay.
you,
Thank
ma'am.
you so much. Thank you, sir.
Once again, I thank Dr. Hemalata for the insightful keynote addresses. Now we move to technical session 1 in computer science engineering. It is my pleasure to introduce the session chair, Dr. S. Davamani, Associate Professor in Computer Application, Sri Ramakrishna College of Arts and Science, Coimbatore. Madam will now chat to the session, technical session. I request all presenters to be ready with their presentation and limit your presentation to the allotted time. Now I hand over the session to the chair, Dr. S. Davamani, madam.
Hello. Good morning. Good morning, all of you. Hello. Can you hear me, sir? Hello.
எஸ் மேம், ஹியர்.
Okay, sir. Okay. Okay, kindly start the first session, first candidate. Hello.
Yes, ma'am.
Hello.
Yes, madam.
Okay, sir. Start.
You can start.
Hello. I am the first candidate. Should I start?
Yes, sir. Okay.
Sorry.
Title is Systematic Review of AI in.
Show your PPT, please.
Yeah.
Yes.
Hello. Miss.
Okay. Please on the mic.
So is my screen visible? Mm. So hello. Good morning, everyone. So my name is Somitra, and I have done a literature review on AI-driven video summarization. I got help from my teachers, Amrita K and Smera C. Both are from my department only. So the main goal of this literature review was to understand how these models are able to summarize different lengths of video, and how we can get this summarization into different things. Like it can be helpful, for example, like when there is a very complex video from somebody's else perspective, because like everyone has a different understanding, everyone has a different way of learning things. So somebody can understand a certain video, like video content easily. Somebody can, for somebody else, it could be very hard. So the main objective was to get the summarization of the video and simplify it if he's not able to understand it properly. Uh, so there are I have included only papers after 2014. So basically all the latest papers, because old papers are not usually have they only took fixed keyframes extraction. So basically you have to provide the keyframe for what you want summarization for. But the new models have developed in certain way that they are able to get the audio, video, and textual content of a video, and able to give the summarization and context of the whole video. So there are two main approaches for the summarization part. One is extractive methods, which takes the important video frames through spatial and temporal clustering methods, and then selects the keyframe for which it feels like it has the most summarization or has the most content based upon it. And there's another method, also the abstractive method, which generates a unique summary content using generative models and NLP techniques. Extractive models excel in selecting representative frames, while abstractive methods create novel, condensed summarization that capture semantic meaning beyond simple frame selection. So abstracting methods don't only have a simple frame selection, but also are better and generating condensed summarization of that video. So there are like main differences of between supervised learning, unsupervised learning, and reinforcement learning. For this type of models is that usually supervised learning has a better accuracy, but are not that scalable compared to unsupervised learning. Supervised learning have a lower F score, but are typically better at scalability. Reinforcement learning have a very decent results and all because of the reward system and all, but it can fall into a loop and all this loop. So yeah, so one of the main things was different model between different papers. Some papers only took audio signals and textual content. Some papers only took visual data and textual content, and some papers took all the three models. So when you took visual data, audio signals, and textual content, those models have performed better than the ones who have only took textual content, because for many times there are few videos where you need all three types of modes to understand the context in a better way, and there are certain videos where only textual content is enough to understand the context of the video. So yeah, this is the comparison between the top 5 papers, and depend on what learning methodology they use. As you can see, unsupervised learning has a better, supervised learning has a overall better F score than unsupervised learning. And the architecture of different these papers and the data set provided to them. So the major research challenges were insufficient multimodal data. There are many types of videos where the textual content was not able to was not available, or the audio content was broken. Sometimes there are videos where the audio is not clear. There was unreliable evaluation matrix. F score is not a good matrix for this type of content, because suppose a summary of a certain video could be good for a certain person, but could be very difficult to understand for a different person. Because so F score is not a good matrix for all this you can say all this comparison and high computation requirements. Many models use multiple modes, like they took audio content, video content, and the textual content. This had a very, I can say, heavy load, and the real-time operation is almost impossible in in this type of models. So the future direction for this is like having a generative AI and LLM usage, then personalized summarization. Like suppose a model needs to understand the person first to generate a summarization for a certain video, and a natural language interfaces. So key takeaways was performance limits. As you know, when you take a video and take extract 3 types of modes from this video, I extract the textual content, extract the audio content, extract the video content. Usually supervised methods and also use a supervised method, you obviously will have a performance limit. Uh, that's it.
Yeah, Romit Mani, very good presentation. Can
Thank
you hear
ma'am.
me?
Yes, ma'am.
Yeah, kindly go to limitation page, I mean comparison table.
Sure.
Kindly go to comparison table. Yeah, in this. You have compared some methodologies, no?
Yeah.
See, in this, what are all the limitations you have find?
Yeah, so limitation is like few of the models, like supervised models, usually take a long time to process all this data because they extract all three types of contact, all three types of modes. Like the Vora et al has a very high, a very good F score, but it takes the audio content, the video content, the textual content. And sometimes the limitation is that some of the videos don't have a good audio. They have a very broken audio, or the video quality is not that good, or the texture or the transcript of that video is not proper. It's has a mismatch. This could be due to the language barrier, because some of the models F score is, I think, in generally is using for English language, but suppose it is a different language, then the models F score could be very low. So that's one of the main problems supervised learning. Unsupervised learning, as you can see, the 4156, because it has not been trained, so it doesn't have that good type of score. And some other models, like some other papers like Mahindra and Kavya, only use transcription. They only use text to it content for the summarization part. So they have a very high F score. But suppose there is a video which has a lot of video content, or is very, or has a lot is dependent on a lot of like graphs, diagrams and all, then it will be very hard to summarize that type of video, since you are only taking the textual content of that video.
Okay, very good answer. I have one more question. If unknown language video or text will come,
Yeah.
how can you give the training, or how can you give the labels for your model? Did you find any model? No, only comparisons.
Yeah, only comparison.
Okay, suppose if unknown languages will come means, what you
So,
give the solution on that?
so many of these papers usually are focused on English language, but only one or two usually had a feature that they use only basic Google Translate to translate if there's a different language, they use a Google Translate to translate the language to English and then feed it to the model. So almost none of these papers are for other languages. They are only like made around the English language.
Okay, thank you.
Thank you.
Thank you so much. The next, Ritam Maiti, the next candidate. Ritam
Yes,
Maiti, are
ma'am.
you?
Am I
Okay.
audible?
Yes, yes.
Yes, ma'am.
Proceed.
So, okay. So I'm starting with the presentation. So good morning, everybody. And my name is Ritam, and this is presentation of our paper titled Explainable AI for Predicting Student Performance in Online Education. So this is a collaborative work with Professor Dipti Das and Associate Professor Rajesh Khanna sir from Department of Computer Science, Christ University, Bangalore. So today I will walk you through our approach and building the approach to building machine learning models that are not just accurate but also transparent and interpretable. So for making critical decisions for educators while making decisions in online learning and related stuff. So let's start with the second slide. So it's for the research context and objectives. So in educational data mining, we have plenty of black box models that achieve impressive accuracy. But here's the thing that if an educator can't understand why a model flagged a student as at risk, that prediction doesn't translate into action. The model might say the student will fail, but the teacher needs to know what to on when to intervene. So there's a unique challenge with educational data specifically. So missing data in education isn't random noise, it carries meaning. A student who never submitted an assignment is fundamentally different from a student whose record is missing due to a technical glitch. We call this the difference between strategic absence and technical absence, but our models need to be aware of it. So our objective was clear that we need to develop a transparent, interpretable prediction framework using explainable AI principles. So not in the next thing, we will be explaining what our data set and methodology will be. So for this study, we use the Open University Learning Analytics dataset, OULAD dataset. So it's one of the largest datasets. To give you the sense and the scale of it, is it contains about 32,593 students' data across 22 courses instances with about 206 assessments and over 10.6 VLE interaction event logs. So it's a rich relational dataset that we took for our research purpose, and it gives you demographics, registrations, assessment, virtual learning, environment activity, etc. So our methodology had about like three pillars of our making this model as interpretable. So first was the domain aware feature engineering. This is where we convert missingness patterns and our raw behavioral logs into meaningful human interpretable predictive features. For example, instead of just noting this value is missing, we created explicit binary features like completed course, withdrawal status, and is continue activity that capture. So what the absence actually means is an educational context. And the second pillar was we built and compared three models. First one is XGBoost, second one is random forest, third one is logistic regression. These all three models were compared on the basis of two feature sets, one with features and one with behavioral features only. And the third and the last one is we applied SHAP and LIME as our explainability frameworks to validate that the model's reasoning aligns to a pedagogical intuition. So the next slide is explaining what our predictive performance results were. So if we see the feature set and including all the demographics, behavioral and academic predictors, XGBoost is the most favorable one. It achieved 85% accuracy with the F1 score of 84.61%. Random forest was also very close behind, and logistic regression also performed respectively well. But here's the more interesting thing. When we stripped out assessment scores and grading data and used only behavioral and demographic features, XGBoost still achieved 81.2% accuracy. That's only 3.7% drop in precision. But someone will ask, like, why does this matter? So, because behavioral data, things like how often a student logs in, how long they engage, whether they are continuously active, is available before final grades comes in. This means we can build early warning systems that don't need to wait for exam results. The modest accuracy drop confirms that behavioral indicators alone carry strong predictive power. So that's why we found that XGBoost is the most favorable model here, but logistic regression and random forest were also close behind. So it depends on what type of research you are going to do, then model gives you the results on that basis. So the next slide is that we will explaining the SHAP global feature importance. So now let's get into explanatory side. We applied SHAP analysis to understand which feature the model relies on most at a global level. And the top predictors that emerged were completion status. By far, it is the strongest. And second one is average assessment score. And the third one is the engagement duration, like how long the students are being using the videos in online learning. So what's encouraging here is that these results align intuitively with what an educator would accept. Students who complete their courses, engage for longer periods, and perform well on assessments, they achieve better outcomes. The model isn't picking up on some obscure statistical artifact. It's learning patterns that make pedagogical sense. So this alignment between the model learning importance and domain expertise gives us the idea that SHAP maybe is the first feature from the explainable AI framework that we should be using in such cases where data and the features are so much related. And the next slide is about the LIME. It's the second framework from explainable AI that we have used. So the data was globally important, but in at the level that if we are using some features, we need to explain at individual level, like local explanation. We also need to have that why it's the feature that is affecting the model accuracy should be explained. So here LIME is used for that. So when we use both SHAP and LIME together, so we get that both methods independently identify the same top drivers. course completion, engagement duration, and active days. For instance, in a specific student's SHAP waterfall plot that I have used in our research paper, we can see that the completed course students are pushing it towards the pass or to the metric of pass. If we are taking pass or fail as two metrics, then the local explainability will tell that the students who have are getting more more feature in the completed course metric, they will pass. So Line's explanation for the same student was remarkably similar. The same top three positive and negative drivers. This convergence between two independent explanation methods aren't artifacts of a single technique. They are reliable signals that if the SHAP is saying that this metric and this feature are the indicators of student being passed or not, then this is the Lime also explaining that, yeah, if it is on the positive side, the metrics are going to be in favorable of the model. So next I will explain the feature innovation and that we have done in the exam paper. So first step was data quality assessment. We concluded a comprehensive evaluation of missing values across all the seven tables in the data set, identifying where the data was absent and why it was not. Second one is domain aware conversion. This is the critical innovation, I would say, because instead of imputing missing values, that's the first standard method that we use. We or dropping the incomplete records. We transformed missingness patterns into explicit features. For example, a student with no final exam record gets completed course is equal to 0 rather than a null value. This encodes the educational meaning of the absence. So the third feature is the behavioral features that we took. So there were about 1 nanomillion like really event logs. We engineered engagement metrics. So we categorized them in about 2, 3 parts like total clicks, how many clicks were done on the video content, active days, how many in a how that's like a streak of how many days a student is regularly logging in into a course. And like other one is continuous activity flags, like how much video he is or she is seeing in the content. So that capture like how students actually interact with the platform. So last step was the validation. We performed a systematic check for data leakage and distributional stability to ensure our features were clean and wouldn't inflate performance artificiality. So this whole pipeline was implemented using Python, and then we got the results in that way only. So the next slide, I would explain the practical implications of our research that we can see. So first one is like early intervention. If we see that on a regular basis, if someone is taking a online education, so online course, then it's a like if there's a 90% chances that a student will always you will see the course or study from the course about 1 to 2 days, or maybe at max it will take 1 week. But after that, the engagement process always goes down. So using this method, we can intervene on the part that if you are not regular, then we can take some measures to in order to get the student more active on the platform. Second one is transparency. Instead of saying black box scores that says 60% chance of failure, our system provides a narrative for that. So using this research, we could flag that in an early way that if the student is going to fail, on what basis are we saying that he will fail? So these metrics that we took from the data set of like engagement, total duration, it says that using the explainable AI, we are able to predict on what features, on what metrics, and on what model we are going saying that student can fail or pass. So the third one is actionable insights. So here what happened is educators can create individualized interventions. So once the explanations are to very specific or to the point, then if, for example, a student with low engagement needs a different approach, so a student and a teacher can decide that what should be done or what needs to be done in order to get good grades, or what's the real issue that the engagement process is not that well in an online education platform. And the last one is scalability. So the framework that we designed is very generalized. The feature engineered pipeline and explanatory approach aren't tied to only this data set specifically. They can be adapted to different educational platforms and contexts. So next slide is the key contributions that we got. So for the contributions, I would say that it's a very novel domain-aware feature engineering approach that turns missing data into meaningful predictive signals. We have already achieved 85% accuracy with full interpretable predictions and demonstrated convergence between SHAP and LIME, which strengthens trust in the explanations. And it's not like that; it's a black box decision that the if an outsider is seeing that on what basis you are saying that the student can fail or pass. So we have used that SHAP and LIME together in order to get the most reliable decisions. And the limitation we would say is that our approach depends on the semantics of missingness being meaningful. If missing data is truly random, the domain-aware conversions adds less value. We made our data set specific to administrative purposes only. So if the data set is from another country, it may differ in this country also. So it depends that if the organization shares the real data metrics from their institution, then we can use this for proper analysis on specific data set and specific institution. And the distinction between technical and behavioral missingness requires domain expertise to set up correctly for each new data set. We need to re-engineer the pipeline steps will be same only, but we need to change the metrics, and we may also need, if the data set allows, we can choose other models also, because the generalization doesn't stop into the 3 models that we have used here. So for conclusion, I would say that this research establishes a principled framework, and we showed that combining domain knowledge about incomplete data with behavioral feature engineering, we can achieve about 85% of accuracy while maintaining SHAP and LIME. So most of the pitfalls were only that we were not able, the meaningfulness that we get from the null data or the data that hasn't been published is the only problem that we have to face. So the behavioral prediction capability is particularly promising for real world development, and for because it strengthens the academic process of online education. And also it can be used in real time dashboards, like if we are deploying this as a live intervention system that can be integrated into learning management, because every institution nowadays have an online course also. So if we try to implement this feature in the backend or in the pipeline only, then it gets a real-time metrics that how well the students are even doing if they are subscribing to a online education rather than a full time. So second one is the heterogeneous context, like validating the framework across diverse educational settings. Like if we go to different institution, different course formats, we need to metrics. We have to collect the metrics first, then we have to check that whether the data is even like viable to use in that type of model or that type of metric. So that's the heterogeneous context. And the last one is the explainability limits. So investigating where interpretability breaks down. Not all data contexts may support clean, but intuitive explanations are the most one. And the understanding those boundaries is the most important, because uh, even AI is like we don't know what it on the when it renders the answer for a user, we don't know on what basis it's rendering an answer. So on the existing explainable AI methods that we have right now, we have tried to use that and try to explain every metrics that we are seeing. So on that basis, explainability will have limits somewhere or somewhere, because the data set changes, the framework changes. So there will be a limit on that. But if we are using explainable AI, then we should use it responsibly so that the black box context of the research doesn't looks like that. So yeah, so this is all from my side. Thank you to listen, and I'm happy to take any questions. Thank you.
Yeah, thank you, Ritam, Niti. It's a
Yes,
wonderful
ma'am.
presentation. It's a
Yeah,
very
ma'am.
good work.
Yeah.
Okay. how can you say your system is explainable AI?
So, ma'am, if we take explainable AI, first of all, when we started this research, the main aim was first to just compare the models that we have used in the research. But while on the go in the research, I realized that if we are just comparing some models, there's are hundreds of research regarding this what model is, why it is good and what not. So we try to use that SHAP and Lime as the only metrics here because mostly these are the first things that the first frameworks that we use in order to enter the domain of explainable AI. So SHAP is the most favorable one, and it takes the pipeline that we run on the data set. It takes all the metrics on that basis. It compares every other metric that we are saying that it's giving us this much score and that much score. So SHAP takes the first thing, and it's the first step of explaining the why we are saying that our model is the best one and that. And on that basis, SHAP is a global feature. So it works very on the way that it's very forgiving in nature. So that's why we can't tell that if it is saying that this particular metrics like completion course is very good. So we can't totally rely on this. So that's why we again took this Lime as the local explainability on it was the second part. So when you run the pipeline and after that we get the result from SHAP, we take that matrix and then we again put it in the Lime framework. So Lime is for the local explainability of machine. And here we put the all the metrics, and after that we get a real scenario that on what basis the features that it is saying it's good for the model, and there we explain why it's so effective in that particular framework of model. So here are the two steps that we took as the explainable AI, and that's why we can say that our research is telling that if you are believing this framework and on what basis you can believe this. So that's the
Okay,
explainable AI.
okay. Your system whether provided teaching and learning as well as evaluation system also, or only
Yeah.
evaluation?
No, it started from if we are taking, I told that if we are taking it, I took a general data set that's available on internet because every institution can't share their real metrics. So if we are taking a global data set, then it's easy for us to get a generalized method. Now, if we take any other data set, then on that basis, we will again run the pipeline. And first we have to get all the metrics and we have to ask the institution also like what they are mainly aiming to get. So some institutions would say that we need the most number of clicks in order to get more engagement. Some would others say that how much duration they need. So on that basis, we start from the first part. So yeah, it would say that it not exactly starts from teaching, but it takes the metrics from starting of teaching only. So evaluation is
Okay,
the last process.
okay, Pa. Yeah, while teaching, some
Yeah,
students are very intelligent. I mean, no,
yeah,
advanced learners. So
yeah.
how can you engage those kind of advanced learners comparing with the remaining students? If in a class there are 60 students are available, only
Hmm.
10 students are more advanced learning students. So how
Yeah.
can you engage these 10 peoples? If it is a manual teaching means we give some assignment or we give some project for those peoples,
Hmm.
right? But your system is a trained system.
Okay. So
How can your system will engage those kind of students?
So if we are talking about intelligent students or those students on the basis of a manual teaching, so if we are in a system of manual teaching, obviously the teacher would be able to identify fast that these students are too responsive. They are getting the all the concepts in one go. So the the research framework that we have tried to build, it's like on the basis that it takes all the metrics like total completion hours, how many times you have watched, or what's the click metrics that the students have. So it will be differentiating the students, but in order to get the most intelligent students out of that class, it would be a little difficult for the model because it's on the generalized way. Because in the online learning, we can't tell that from a perspective of AI that is he intelligent or not. And for that, we have to take some other test or some other metrics and maybe a more comprehensive AI explainable framework. But it's more generalized that if the metrics that the students or the institution has chosen, if on that basis we are going to get some students, then we are able to the metrics that we choose. If the students are performing well on that, then we can segregate them on that basis that these students are the best one because they have the most engaging factors and the metrics that we are comparing them on, they will be they are doing on good on them, and we can tell them we can like criterize them that they are the intelligent ones. So mostly this framework is built in order to make more engagement on the general basis that it should not leave behind any student who is lagging behind on the online education, because in online education, if any student is already intelligent, I would say he would have chosen more steps in order before the model even interprets. He would have gone in some other levels, but it mostly relies on the metrics. So it will be able to differentiate between a good student or a bad student.
Okay, kindly include the future in future.
Okay.
Include the solution for this. Okay. Coming to the point of evaluation, your system will be a system is MCQ questions or 5 marks or 10 marks or 20 marks questions.
It's in online education. It's the data set that we took. It was MCQ type questions because written questions would need a OCR detection from the AI part also, and it requires a little bit more on the part of technical specs and also some systems that at that time I didn't have. So I relied on the MCQ type questions only.
Okay. Then one more question. Pass mark is 50%. Am I right?
No, not exactly 50 marks. I would say it was 40%, I guess. Yeah, it was 40%.
Okay, if it is a 40%.
Yeah.
So if it is a manual system, means if the students will get 37 or 38 means,
yeah,
we will put 2 marks or 3 marks or for bonus to pass the system. Yeah, in the results passing board. So in that situation, what is your system will do?
So if before that, if we arrive on the part of marks directly, then before that the model will start giving you signals that these students may or may like it. The performance issue will be shown before that only. It will gives you sign that these students are not doing that well or maybe they are lagging behind. So in that part, we have to intervene manually, that we have to tell them that you should start focusing more on this subject, or this you are not focusing that much. So model will give you the signals at the first only. And if it we directly arrive on the part of marks, then it will only give you pass or fail. So before that, it will give you that the metrics that why the students on what basis it's saying that it may lead to fail or may lead to something that is not desirable.
So again, you go for manual evaluation. Am I right?
Yeah, so manual evaluation, it's like giving it's a warning system that alerts the teacher at least that you should now manually intervene for the student, that you should say that you should start on what basis. So teacher should be clear in her mind that why I'm telling this student to work hard or work some or you need to focus. So that's the part of framework that we have built.
Okay, kindly include the solution for these also, because students are having 5 marks bonus.
Yeah.
They will get pass means we are giving up to 5 marks, right? Okay, kindly include this also. Then one more question. How can you provide the security for
can you repeat, ma'am? I was not able to. I was not able to hear the question.
In your system. While coming to the point of security purpose.
Yeah.
See, you are having online students, there are 35,000 or 40,000 students, right? How can you provide the security for those students' data? Because one student got fail mark in 2 subjects. Suppose they will attack and change the marks, instead of 35, they give 85. How can you provide the security for those data in your system?
So, for security purposes, that's why we try to first implement a generalized way because obviously any institution will be reluctant at first to share the data set of their own students because it's always comes with a security issue. We all know this in this age of digital era, nothing is that private. So the first part is that we need to get a framework that it is working right now. And on that basis, when if we try to implement internally into a system, we need not to tell the students that we have a system like that. If we even tell, we have to first tell them that why we are doing this and why we should you should try to follow this. So that's why on the security basis, I would say it's not a product that we have built. It's a framework that we have built that we can include in our already present system. So if we try to convert this into a product, then we have to think of the CIA triad of the cybersecurity thing for the security purposes of the data. So it's like a internal, very internal tool that you implement in your already present education system. And if we are implementing it internally in your organization or some other or institution, then it needs not to be so much worrying about this data to be leaked because we are not using it as a product for students. We are using it only for the administrative and the educational purpose of the teachers. Because if this framework is in the hands of the administration and the teachers only, then it's need not to be worried. And we also don't need that much awareness for the in the way that if we are telling the students why are you failing, we have to just explain them on what basis. But we don't need to explain all the methods and on what basis we are telling you. So that's the security part because it's not a product that we have built, it's a framework that we have tried to implement in the research.
Okay, kindly include the security purpose also, right?
Yes.
Then only your system will get more effective.
See, no, security purpose,
Okay,
if we, yes, ma'am.
Yeah, because marks, if they attack the marks means, how can you provide?
Because ma'am, the part of
Yeah.
attacking is that if students are working, if students are knowing that we are being evaluated on what basis, because we are not giving the students to get like evaluated on themselves only. We are you providing this for the teachers only. If we need the data, it's already that if we are using the data from an institution, it's already in a secure way that we are using this. So institution would already know that we are using the data and on what basis we are using the data. So data needs to be in the system already because we will implement this framework in the research on the product that we have. If we try to build out of this, it will be internally for the institution only, not a full global product that will be used by any stakeholder.
Thank you.
Okay.
The next candidate.
Good morning, ma'am.
Good morning, ma'am. Yes,
Ma'am, shall
kindly
I
proceed, ma'am.
Paramanand Praveen.
Yes, sir.
Yes, you can proceed. Ma'am, you will please include Paramanand Praveen. Ma'am, Dr. Dhavamani, ma'am.
Yes, sir.
So next participant is Paramanand Praveen, ma'am. Please.
Okay, sir.
I'm going to present.
Proceed, ma'am.
Ma'am, is my screen visible?
Yes, ma'am. Yes. Yeah, it is visible.
Yes, ma'am. Thank you. So, good morning, everyone. Today, I will present our research titled A Conceptual Framework for Cyber Forensics in Multi-Cloud Environment. So, with me, I had my Sir Dr. Ashok Emmanuel, as well as Dr. Chandra Jain for assisting me with this research work. So, I'll begin. So as we know nowadays, one major reality in modern computing is that organizations nowadays are no longer dependent on a single cloud provider. Instead, they increasingly distribute workloads across multiple cloud platforms. So this shift improves like agility, but at the same time, it expands the attack surface. So an attacker can move across services, accounts, as well as providers, which makes the evidence trail fragmented and it will be difficult to reconstruct it. So in this context, cyber forensics refers to the identification, preservation, as well as the analysis of digital evidence in a way that it remains technically valid as well as legally admissible. So the main concern is that the cloud environments become more distributed and the forensics is helping with the investigation. So our research had three objectives. The first one was that we wanted to identify the major hurdles that made the traditional forensic tools ineffective in a multi-cloud setup. Many existing tools were designed for centralized or single environment systems, so they struggle when logs or storage or the metadata are spread across different providers. Second, we aim to examine evidence integrity, especially the chain of custody problem, because evidence in cloud environments may pass through different systems, regions, as well as legal boundaries. Third, we proposed a conceptual framework that integrates modern technologies, especially blockchain, to support more secure and trustworthy investigations. And next one, I'm talking about methodology. So to address these objectives, we followed a conceptual research methodology. We began with a systematic review of more than 10 recent studies published between 2023 and 2026 on cloud security breaches and forensic challenges. For this review, we also identified two major layers of difficulty. The first one is that what we describe as technical fog, meaning incompatible logs. So different data structures and inconsistent evidence formats across cloud providers. The second is legal fog, which refers to different national regulations. Like the rules will vary depending on each country. Then is the proposed conceptual framework. So according to the framework, the first framework is about data collection. So here is where all the extraction of logs, data, all the important metrics are taken. Then it's an integration layer. So because these organizations use different platforms, the data will be in different formats. So we need to integrate them into a one single standard format for an easy conversion, for easy understanding. Next is a security layer. So this is where the blockchain involves, as well as the chain of custody is protected using the blockchain. Then smart contract enforcement. So this validates as well as standardizes the format, like formatting of the evidence, as well as checking if it is correctly validated across the system. Then evidence preservation. It maintains a transparent as well as a tamper-proof chain of custody. So the key challenges, one was, like I said, because they were used in different cloud platforms, it was difficult to put it into the same format for the standardization. And then, of course, proving evidence, in a digital environment, proving evidence that an evidence hasn't been altered or hasn't been changed or damaged, it is another challenge. And the data stored in different, even though data can be stored in different countries, but each country has its own laws as well as regulations. And of course, lack of cooperation. If an attack happens, it is very hard to get the access permission from the providers or the platform organizations. So for a summary or a conclusion, our research shows that the traditional reactive forensic approaches are not sufficient for multi-cloud ecosystems. So what is needed is a proactive forensic framework that is designed for distributed, heterogeneous, as well as the jurisdictional complex environments from the beginning. And second, the proposed framework should be tested in simulated breach scenarios to evaluate how it performs under realistic attack conditions. And third, there's a need for global legal as well as procedural standards for cloud evidence so that technical investigation and legal administrativity can evolve together. Yes, ma'am. Thank you.
Okay, thank you, ma'am. Nice presentation. Wonderful work.
Thank you, ma'am.
Yeah, I have some clarifications, ma'am.
Okay.
Okay, while implementing your system, what are all the difficulties you have faced, ma'am?
Ma'am, since I'm just proposing a framework, I
Because you
haven't.
are using a cloud, no, that's why.
Yes, ma'am.
Yes.
Ma'am,
What are
so,
all the difficulties?
ma'am, so the framework that I'm proposing, like I mentioned in this, organizations, they use multiple cloud platforms for storing data, for storing metrics. So when you're trying to get evidence from these many platforms, you have to also maintain it in a single standard format for the cyber forensics people to understand as well as evaluate it and also trace it, track it. So that was one of the challenge for understanding how to keep it in the same format. And then another was chain of custody, as I've said. As in we have to somehow prove that the evidence hasn't been tampered, it hasn't been changed, it hasn't been damaged. And since an attack has happened, the organization to give us actual trust, like an access for the data, it will be pretty much hard.
Okay, what is the name of the single standard format of data, ma'am?
Sorry, ma'am, can you repeat?
What is, you are using a single standard format, no, for the data, because each and every country, they are giving different formats of data.
Ma'am, as in the standard format for the.
Yeah, what is the name of that single standard format name?
Ma'am, is it the one that I proposed or the one that everyone is, it's already existing?
Yeah, what is the name, ma'am?
Ma'am, that isn't. Ma'am, I haven't really looked into the name of it.
Okay.
Because I've only checked the formats across like different types of formats that can be used.
Okay, what kind of algorithm or methodology you are used in your system?
Ma'am, I haven't implemented, I haven't made the system. I'm just proposing. This is a conceptual framework proposal. Ma'am, so me and my sir, we decided to just check the research part, as in how this framework will help in the data breaches, including the investigation. And of course, chain of custody. Basically, it helps in tracking the evidence of who it went to, who has handled it, where it has gone. So a blockchain, using a blockchain, we can secure the investigation evidence. So that's all.
Okay, ma'am. What is the simulator you used in your system to implement or testing the data? What kind of simulator you are used?
Sorry, I haven't tested the data part yet.
Okay, okay. Okay, thank you so much. Okay, thank you, ma'am.
Thank you,
Thank you
ma'am.
so much for your wonderful presentation.
Thank you, ma'am.
Okay, thank you, ma'am. Yes, next candidate, please.
Next
Mariam
participant, Sayyid Muhammad Lakman is there.
Okay.
So I think it is not available. So next participant, Mariam Saraj. Mariam. So, Jia, you are ready?
Yes, sir.
You can proceed.
Okay, sir. Ma'am, is my slide visible?
Yes, ma'am, yes.
Okay.
Kindly proceed.
Yes. Good morning, ma'am. My name is Zia Malcolm, and I'm from Department of Computer Science at Christ Deemd University, Bangalore. So this research was conducted under the guidance of Dr. Buena Jayabalan and Dr. Mohana Priyati. So my paper is titled as Fake News Detection, a systematic review of approaches, performance, and limitations. So the purpose of the study is to analyze how fake news detection techniques have evolved over time and to identify their strengths, limitations, and future like research opportunities. So like nowadays the rapid growth of fake news is a major issue. So because many online like today informations are reaching to users within seconds through social media platforms. However, this increase in efficiency has also enabled the spread of false or misleading information to the users. So like fake news often like it appears credible and uses emotional language or like any catching headings or anything to attract attention. So the relevance of this topic is like understanding how fake news detection systems work because it allow the researchers to improve them, and also by analyzing like the existing work we can identify the strengths, weakness, and also like we can suggest for future improvements. So the objectives was to examine like different approaches, like from early machine learning methods to the current advanced techniques, and then to analyze the performance, like about the strengths, weakness, about the accuracy and all those things, and then how social context or user behavior influence the spread of information. Then to explore like multimodal detection approaches that which combine multiple types of data. For example, like nowadays fake news has both textual context and well as images, videos, and all those. So multimodal detection approaches how it works. Then to identify like the research gaps and the limitations in current systems, like for a future for future improvements. So according to my review paper, like I've followed a systematic literature review approach. So relevant studies were collected from different databases with by highlighting the keywords such as misinformation, fake news, machine learning, all those keywords. Then a systematic review of all the papers were done where and it was categorized as from the early machine learning to the latest approaches. So the categorization, like the major categorization was like classical machine learning, and then came the deep learning, then graph-based approaches and multimodal detection systems. So these are the major categories of approaches or fake news detection methods that were evolved. Like first, it was the classical machine learning, where researchers use algorithms such as support vector machines, logistic regression, and naive space. These techniques, like they mostly relied on textual context, like the word frequency, like the writing style, punctuation patterns, and sentiment scores. So all those things. So support vector machine is kind of algorithm that creates a boundary between two classes. For here, the class is real or fake. So according to that, it detects. Then logistic regression and naive Bayes is a probabilistic kind of approach where according to the probability that a given news is real or fake, like that we'll find out. Then came the deep learning approaches where neural networks like convolution neural network and recurrent neural networks, then long short-term memory networks, all these were introduced. So like see a convolutional neural network, it detect like important patterns or phrases in text using operations like for example catchy headings or um, noticeable phrase. So according to text phrases it identifies. Then recurrent neural network, it analyzes sequential data, like on a sequential basis it analyzes. So a sequential flow of data, it keeps information about the previous word. So according to that, in a sequential manner it identifies whether it's real or fake. And then LSTM, long short-term memory, that is also a that is also like recurrent neural network, but then it has a long term, like it uses memory basis where it can store information that is needed, it can discard that's not needed. So like that it keeps if it's a long sentence, for example, this recurrent neural network may not work for long sentences. So if it for a long sentences and all, this LSTM works. Then came the graph-based approaches, like because fake news is not only about the content of an article, but also like how it spreads across social networks. So graph-based models, like it analyze relationship between users and news content, like how to who has shared this. Is this news from a well-known ID, or is it from a true ID or a fake ID? All those things. So how both the relationship of the user and the article is verified. So that is the use of graph-based approaches. Then multimodal approaches, it's like recent systems, it combine multiple data types like text and images, so that improve the detection performance better. So like this is the visual representation, like it's just created with reference to the overall performance. Like first the machine learning, then it showed a increase to 90% when it come to deep learning, and then it again showed an increase to 97 when it came to the hybrid models. So like as a so what is the like overall discussion or the overall conclusion? Like it's that the analysis shows that the fake news techniques have evolved significantly. Like early approaches, mainly they relied on textual classifications, but then when deep learning models came, it improved performance by like capturing the contextual relationships in the language. Then about the network interaction, that was proved when graph based models came into picture. Then like multimodal systems further improved because both the textual and visual information were able to check at the same time. So then despite all of this, like there were certain challenges that remained, like limited multilingual and cross-platform data sets, then the lack of transparency in many deep learning models. Also, like it's a difficulty adapting to new and evolving misinformation strategies, because as these techniques are evolved, also the fake news issues also increasing. So there are certain limitations also. So as a conclusion, like fake news detection has evolved a long way, like from traditional to the advanced multimodal. So detection accuracy has improved like significantly, like as models incorporate more information such as social networks and multimedia. So however, like challenges remain in data set, because if we train a model in one data set, but when it goes to a cross-domain data set, it may not give the correct or accurate results. So that data set diversity, that challenge remain. Then model interpretability, and also, so all these challenges remain. So future research, I would say, like it should focus on developing transparent and adaptable fake news detection, and also concentrate on more diverse data sets. So that is from my part. Thank you.
Okay, thank you, ma'am. It's a nice presentation. I have some clarifications.
Yes, ma'am.
Yeah, you choose your system is systematic approach, no?
Yes, ma'am.
A review, literature review, right?
Yes.
How can you say your system is systematic approach?
Ma'am, because the papers that reviewed were like, it started from the early 2018 or to the after 2015, and then now it reached up to the current phase. So also it's in the paper, it's like it is like how the evolution has occurred, how first it was the machine learning and then it came to the deep learning. So it's like a systematic way how everything changed according to different years. So that's why it's like named as a systematic review.
Okay. What are the motivations to choose this fake news detection system? What are all
Ma'am,
the
it is
motivations you choose?
fake news is a very much evolving issues even now, and whenever, like, one reason, like even during a pandemic, like COVID pandemic, it was many newses came across like about the false news about taking vaccines and all those things. So even when something happens, then fake news also arises with it, because every news that is circulated, there will be something that is added on, which is fake. And nowadays, people actually tend to believe it because it is released in a way such that it looks very real. So earlier, even now, like with the phrases and all those things, we can identify. But now it looks very real. And also, even now, because of AI, even the AI generated or videos, pictures, everything is attached to it, so it looks more real. So again, it's a major issue whether to rely on it or not. So more accurate models would be good if invented, so that we can reduce this issue.
Okay, ma'am. Thank you. Thank you so much for your wonderful answers.
Thank you, ma'am.
The next candidate is Janagi Raman, sir. Are you inside, sir?
Good morning, ma'am.
Good morning, sir. Kindly proceed, sir.
Okay. Good morning, ma'am. Good morning, everyone. I am presenting my title AI-enabled Smart Edge framework for crop disease detection. This research, ma'am, under guidance by Dr. N. Sarmagagarbagam and Dr. Ravichandran sir, ma'am. This research focus on improving real-time disease detection using Edge, AI, and Internet of Things, IoT. The agriculture is vital. Mainly the agriculture is vital for food security, crop disease, reduce yield and quality. In the traditional method or manual or slow, AI, IoT and edge computing enable to real-time monitoring. The problem statement. The problem statement, the key challenges including delayed detections, depends cloud dependencies and poor connectivities in the rural areas. These issues prevent timely intervention. The main objective and the enable real-time detection using Edge AI, reduce the bandwidth and support precision and agriculture related. The proposed framework is we propose in there are three layers in architecture. Number one, data gaining or purchase or acquisition, and second one, edge processing, and third one, cloud analysis layer. But the proposed framework using there are three layers, and then the number one first one layer. Now this layer collect mainly temperature, humidity, and soil moisture and leaf images, and ensure continuous monitoring these layers. And second one, second layer is called edge processing. Core innovation, the local AI processing, including pre-processing, feature extraction, and the classification, reduce latency. And the third layer is cloud layer. The cloud layer handles the data storage and analytics and this model retraining. The ensure long-term system improvement, the main purpose of for using the mathematical model, using this D equal to F of XC and XI. What is the XC? Environmental data. The data that is XC and denoted by XI is image features. But and then workflow. That workflow is mainly what are the steps? The steps data collection and then pre-processing, the feature extraction and AI inference and alert generation. These are workflow. Evaluation matrices. Evaluation matrices mainly accuracy, latency, and the last one is these are evaluation of matrices for in one more, the result reduce latency and improved accuracy, low bandwidth and usage. Comparative and analysis. So, plus cloud faster and response and scalable, less internet dependencies or internet purpose. Conclusion, the real-time detection achieve and efficient and scalable, suitable for rural deployment. And then future work. Another future work is in case one interaction, the largest scalable deployment, and then but the main purpose of this, sensor provide real-time monitoring. Scrap with thank you, ma'am.
Thank you, sir.
Thank
Thank
you.
you so much for your wonderful presentation, sir. No more questions. Thank you.
Thank you, ma'am.
Thank you, sir. Sir, next candidate, please.
Madam, that's all the participant in the morning session, ma'am.
Okay, sir. Okay. Thank you, sir. Thank you so much for giving me this wonderful opportunity. Thanks a lot. Shall I leave, sir?
No, yes, madam.
Okay. Thank you, sir.
So the next session will be resume on 2:30. All the participants, please join on exactly 2:30 p.m. So Mahendrapan sir.
That